Question number 8 is a factorization pattern that they're asking to look at. They present it in a little different fashion. So you kind of got to look at your clues of what they give you and then work from there. So like I said, what we're really working on is factoring of quadratic equations, and in this particular problem, it's the factoring of two perfect squares. Here's the factorization pattern of the difference of two perfect squares. If your first number is a perfect square and the second number is a perfect square, and you subtract them, they can be factored into a minus b times a plus b. I want to show you how that is going to be verified. If I come back, the reverse of factoring is distributing. So if I take a times a, it's a squared, and we use the FOIL acronym. That's going to be a positive ab. On the innermost, it's going to be a negative ab. And the last term is going to be a minus b squared. Well, these like terms are always going to be identical but opposite in sign, so they cancel, so it's a squared minus b squared. So that's the general principle that they're working off of. What they have is something a little bit unique. I would always take a little peek of what they're doing. They're giving you m plus 2m. They're asking the value of m minus 2n. So here's where you can kind of benefit if you recognize the type of problem that they're giving you. First of all, these two over here, this is a perfect square and this is a perfect square. And we have the difference of two perfect squares, so I know I can factor them into the difference of two perfect squares factorization model. So that means m squared is your first terms, m and m. Your last sign is negative, so that means these have to be opposite signs, plus and minus, just as I illustrated here. And then the factors of 4 and n squared, well, 4 is a perfect square of 2 times 2, and n squared is a perfect square of n times n. And those two multiplied together give you 32. So in this case, what they're telling us is we know that m plus 2n is equivalent to 8. It was absolutely given to us. So that's kind of the key that tells you, go ahead and factor this over here. And if you do, one of the factors is going to be m plus 2n. If it's equal to 8, then what does the second number of m minus 2n have to equal if their product has to equal 32? Well, if I know this factor is 8, if I divide both sides by 8, then I know the other factor, which is the m minus 2n, has to equal 32 divided by 8, which is 4. So what I know is the value of m minus 2n is equal to 4. It's a little different approach to that type of quadratic equation that we've seen in the past, but that's a pretty simple way of attacking it.